Good morning again, grade 8 students. It's me, Teacher Christine. So we will be discussing the second lesson for this week. Before we proceed with our new lesson, let's have a short review on what we have discussed last lesson. First, some animals, including bats and dolphins, use echolocation to navigate and find food. You were able to learn also that people use ultrasound technologies such as sonar and ultrasound imaging to observe things that they cannot see directly. So now we are ready to proceed with the new lesson, that is Lesson 1 of Chapter 9, The Nature of Electromagnetic Waves. At the end of the lesson, you have to establish the following learning objectives. First, gather and make sense of information about electromagnetic waves and use models to explain the behavior of electromagnetic waves. And the words that you have to know at the end of the lesson are the following: electromagnetic wave, electromagnetic radiation, polarized light, photoelectric effect, and photon. So before we proceed with our new lesson, I want you to prepare the following materials with you. First, you have your textbook. The next one, you have your pen. And lastly, your highlighter. I want you to open your textbook on page 296. Read My Planet Diary. This is a blog posted by Justin. After reading the passage, I want you to answer the questions. So after reading the blog of Justin, is it possible to communicate with anyone at any time in any place? What do you think? Of course, it's yes. You can use your telephones, your cell phones, or the internet to communicate with others. So what makes up an electromagnetic wave? As you sit at your desk and read this book, you are surrounded by waves you cannot see or even hear. These are radio waves, microwaves, infrared rays, visible light, ultraviolet rays, and tiny amounts of X-rays and gamma rays. These waves are all electromagnetic waves. So what are the characteristics of electromagnetic waves? An electromagnetic wave is a transverse wave that involves the transfer of electric and magnetic energy. An electromagnetic wave is made up of vibrating electric and magnetic fields that move through space or some medium at the speed of light. An electromagnetic wave can begin with the movement of charged particles, all of which have electric fields around them. As the particles change speed or direction, a vibrating electric field is created, which in turn produces a vibrating magnetic field. The vibrating magnetic field creates a vibrating electric field. The electric and magnetic fields produce each other repeatedly. The result is an electromagnetic wave as shown in this picture. Note that the two fields vibrate at right angles to one another. The energy that electromagnetic waves transfer through matter or space is called electromagnetic radiation. Electromagnetic waves do not require a medium such as air or even a rope, so they can transfer energy through a vacuum or an empty space. So please take note that an electromagnetic wave is made up of two fields at right angles to each other. So before we proceed with the next topic, I want to check your understanding about the concept. First question, what two fields make up an electromagnetic wave? Great. It is electric field and magnetic field. Next question. At what speed do electromagnetic waves travel? Great job! The answer is at the speed of light. Waves in the electromagnetic spectrum. Please be reminded that there are 7 kinds of electromagnetic waves, namely radio waves, microwaves, infrared rays, visible light, ultraviolet rays, X-rays, and gamma rays. The behavior of electromagnetic waves cannot be explained by a single model. 2 different models are required. An electromagnetic wave vibrates back and forth like a transverse mechanical wave when it travels through space. However, when an electromagnetic wave strikes some substances, it acts like a stream of tiny particles of energy. 2 different models are needed to explain the behavior of electromagnetic waves. A wave model best explains many of the behaviors, but a particle model best explains others. The first model is wave model of light. When light passes through a polarizing filter, as shown in this picture, it has the properties of a wave. An ordinary beam of light consists of waves that vibrate in all directions. A polarizing filter acts as though it has tiny slits aligned in only one direction. The slits can be horizontal or vertical. When light enters a polarizing filter, only some waves can pass through it. The light that passes through it is called polarized light. To help you understand the wave model, think of light waves like transverse waves on a rope, as shown on the left picture. They vibrate in all directions. If you shake a rope through a fence with vertical slits, only waves that vibrate up and down will pass through. The other waves are blocked, of course. A polarizing filter acts like the slits in a fence. It allows only waves that vibrate in one direction to pass through it. I want you to look at the second picture on the right. How are the 2 drawings different? In drawing A, the slits in both fences run up and down, as does the wave. In drawing B, the slits are at right angles to each other. So, what would the drawing look like if the rope waves were side to side instead of up and down? Of course, no waves would pass through because in both cases, the first fence has up and down slits, which block a side-to-side wave. The second model is called particle model of light. Sometimes, light behaves like a stream of particles. For example, when a beam of high-frequency light shines on some metals, it causes tiny particles to move. These particles are called electrons. Sometimes, light can even cause an electron to move so much that it is knocked out of the metal, as shown in this picture. This is called the photoelectric effect. This effect can be explained by thinking of light as a stream of tiny packets or particles of energy. Each packet of light energy is called a photon. For the effect to occur, each photon must contain enough energy to knock an electron free from the metal. So to wrap up everything in this lesson, you have learned that an electromagnetic wave is made up of vibrating electric and magnetic fields that move through space or some medium at the speed of light. You were able to learn also that two different models are needed to explain the behavior of electromagnetic waves. Namely, a wave model best explains many of the behaviors, but a particle model best explains others. So that's it for this week. Thank you so much for watching this video. I will see you again next week for a new lesson. Again, thank you so much and have a nice weekend.